Hey everyone, this is an introductory lesson on ECG. So in this lesson we're going to talk about ECG paper and how it's laid out. We're also going to talk about the PQRST wave, talk about what each of those waves actually means. And we're also going to look at a method of reading ECGs and look at how we can determine heart rate, rhythm, axis, and intervals from an ECG. So to begin, we'll first look at ECG paper and how it's laid out. If we were to take a close-up look at ECG paper, we would see that ECG paper is made up of many small boxes that are grouped within larger boxes, and each of these larger boxes are a grouping of 5 by 5 of these smaller boxes. So the horizontal length of each of these large boxes is 0.2 seconds of time. So the horizontal axis of ECG paper denotes time. With regards to the vertical height of each of these large boxes, that actually denotes 5 millimeters. So the vertical axis of ECG paper denotes voltage of the particular wave you're looking at. So again, very important to recognize the horizontal axis denotes time, the vertical axis denotes voltage. So if we were to take an even closer look at each of these small boxes at a horizontal axis or the horizontal area, each of these small boxes denotes 0.04 seconds of time. So 5 of these would again add up to 0.2 seconds. And the vertical height of each of these small boxes denotes 1 millimeter. So that's very important. That'll help you a lot if you can recognize that each of the small boxes vertically denotes 1 millimeter, because we use this number a lot to calculate if there's any left ventricular hypertrophy or left atrial enlargement, those types of things. So it's very important to know that. But it's also important to recognize that the horizontal axis denotes time and that each of these boxes represents 0.04 seconds of time, because we're going to use this a lot as well to calculate and make sure that, say, the PR interval is not prolonged, those types of things. So it's important to use when we're looking at intervals. We're going to talk a bit more about that later. So we're next going to move on to the PQRST wave. So if you haven't already, commit this to memory. First, it's pretty easy because it's alphabetical, but think about it again. So we'll go through this again together. We have the P wave first, we have a downward Q wave, an upward R wave, a downward S wave, and then generally an upward T wave. So again, commit this to memory if you haven't already. The P wave denotes atrial depolarization. That's what the P wave means. That's what actually happens with regards to the P wave. The QRS complex denotes ventricular depolarization, and the T wave generally denotes ventricular repolarization. Now, in some cases, you may see a U wave, and that is thought to be due to Purkinje fiber repolarization. You're not going to always see this, but I just thought I would add this here for completion. Now, each of these waves can be categorized or organized into intervals and segments. So one of the big ones we're going to talk about is the PR interval. The PR interval starts from the beginning of the P wave to the beginning of the QRS wave, or the QRS complex. The QRS complex itself starts from the beginning of the Q wave to the end of the S wave. And the QT interval starts from the beginning of the Q wave to the end of the T wave. So these are the three I want you to remember. There are also PR segment from the end of the P wave to the beginning of the QRS complex, and there's the ST segment, which goes from the end of the S wave to the beginning of the T wave. I don't want you to think about them too much right now. We're going to get into more detail later in later lessons, because ST segment is very important when we're looking at any signs of possibly an ST elevation, MI, those types of conditions. So they're very important, but we're not going to talk about them right now. So we're first going to talk about heart rate. So how can we determine heart rate from an